Okay, so for 26 and 27, we see that our angles have denominators of 12. So we're going to want two angles that add up to be 5 pi over 12 and reduced to be special angles on the unit circle. So if we change 5 pi over 12 into 2 pi over 12 plus 3 pi over 12, 2 pi over 12 reduces to pi over 6, which is a special angle on the unit circle. 3 pi over 12 reduces to pi over 4, which is a special angle in the unit circle, but they add to be 5 pi over 12, which is not a special angle in the unit circle. So we're going to need our identity for the tangent with a sum and product. And we're going to use this pi over 6 plus pi over 4. That's the reduced form of 2 pi over 12 and 3 pi over 12. So our tangent in the sum and difference identities is the tangent of the first angle, pi over 6, plus the tangent of the second angle, which was pi over 4. And that's divided by 1 minus the tangent of the first angle, pi over 6, times the tangent of the second angle, pi over 4. Okay, then if you remember the tangents from quadrant 1, the tangents are the slopes of those lines. So slope of a horizontal line is 0. The diagonal line, 45 degrees, or pi over 4, is 1. Pi over 2, the vertical is undefined slope, and then pi over 3, we square root the 3, and the last one is root 3 over 3. So pi over 6 has a tangent of square root of 3 over 3. And then the tangent of pi over 4 is 1. Then we're going to divide that by the denominator, which is a 1 minus the tangent of pi over 6, which was root 3 over 3, times the tangent of pi over 4, which was 1. So slide that over a little bit. There we go. So to add fractions, we need a common denominator. So we're going to change that 1 to a 3 over 3. We'll change this one to a 3 over 3 as well. And then we should be able to simplify this. So we'll add these fractions to get square root of 3 plus 3. We'll divide it by 3. And then dividing by a fraction means to multiply by the reciprocal. So now our numerator goes down here, 3 minus root 3, and then the common denominator goes on the top. Okay, then we can cancel these 3's on the diagonal, and we'll have root 3 plus 3 divided by 3 minus root 3. And we need to rationalize that denominator, so we're going to multiply the top and the bottom by the conjugate of the denominator. So we want the same values, but the opposite sign in the middle. So this will be 3 plus root 3 to get the conjugate in the denominator, and then we multiply the numerator by the same, so we don't change the value of the fraction. Okay, so in our denominator, we picked this to make a difference of squares. Conjugates always make a difference of squares, so we square the first term. 3 squared is 9. Then we square the last term. Square root of 3 squared is 3, and it's a difference, so we subtract. Then in the numerator, root 3 plus 3 times 3 plus root 3, we're going to need to FOIL, so we'll have 3 times root 3 plus, then square root of 3 times square root of 3 is 3. Then another 3 times 3, that's 9. And 3 times square root of 3, 3. 3 square root of 3. So in the numerator, we have 6 square root of 3 when we combine like terms, and then 3 plus 9 is 12. In the denominator, 9 minus 3 is 6. And we can factor a 6 out of our numerator. So we have the square root of 3 plus 2. And then the 6's will cancel. And we have square root of 3 plus 2. To check, we're going to compare that answer, the decimal equivalent of that answer, square root of 3 plus 2. We're going to compare that decimal to the original, which was the tangent of 5 pi over 12 in radian mode. And we see that our decimals are equivalent, so we know that root 3 plus 2 is the exact value for the tangent of 5 pi over 12.